Okay, so I'll start. So nice to meet you. I'm Hugo Lassiege from Malt. I'm currently the CTO at Malt, and I'm one of the co-founders. First of all, I want to say a short disclaimer. I'm not an expert of Elasticsearch, but I am an expert of Elasticsearch at Malt. So what I will describe here is maybe not how you should use Elasticsearch, but how we use Elasticsearch. And yeah, I hope that you will learn something, of course. So we will. Oh, sorry, it's the French screenshot, but I think you can recognize what Louise saw you a few minutes ago. So it's the home page, and basically we will describe how the search engine works, and the search engine is mostly used here on the home page and a page after, but I will describe this later. I won't describe you the way we use Elasticsearch for our back office, because we use a lot Elasticsearch for some internal functions, but we will focus on this part. 300 key search, that's approximately the number of search that we have each month on Malt. That's not that that's not a lot, but that's still a good amount. It helps us a lot to learn things about the different people that perform some search on Malt, and but we have an advantage due to this volume. We have a small volume, we can say that. So there's some things that we can do at our stage because of this volume, and I will describe this. But before that, I just want to explain why we use Elasticsearch at Malt. So I will make you a short history of our usage of Elasticsearch. We started Malt in July 2012, but yeah, it was an alpha version, of course. That was our first meetings between the three co-founders. And at this stage, we didn't start with Elasticsearch. We start with Lucene, which is the engine that is behind Elasticsearch. And it was new for us, but we learned a lot. Lucene is quite powerful, but yeah, you have to struggle a bit with some queries like geolocation, for example. But it was nice. However, in December 2012, it was more ready to be shown publicly. But we start to run the application on Heroku. I don't know if you know Heroku, but it's a PaaS. And you have some constraints on Heroku. For example, the storage is volatile. I don't know the word. Yeah, volatile. Okay, so you can have your storage destroyed anytime, and Lucene and Dix are on disk. So that's quite a problem. So we switched to Elasticsearch in December. We saw a presentation of Elasticsearch by David Piloto. It was in Lyon. And yeah, basically you had two competitors in 2012. That was Solar and Elasticsearch. Now it's quite a good choice to say, oh, okay, Elasticsearch is the choice to go. But in 2012, it was not that clear. But for us, it was quite interesting because it was built from the beginning to be run on the cloud. It was also really easy to start with. You don't have to care about the mappings at the beginning, of course, because after a few months you understand that your mapping are not that good. But yeah, it was quite easy to understand, and it has a fast learning curve. After that, we didn't evolve that quickly. As you can see, we stayed in version 1.2 for 2 years, and we switched to 1.7 only in 2017. Why? Because Elasticsearch is a great product, but sometimes when you change a version, you can have some problems because API can change. You can have problems with some features that could be removed, and yeah. You have to spend a lot of time to modify your application for that. But this year we decided to evolve a bit, so we chose to move to the version 6. We had some problem with the synonyms, but at the end we succeed to resolve it. After 7 years now, Elasticsearch is one of the most stable components at Malt. To compare with the other components, MongoDB, for example, we choose to use MongoDB in 2012. Now we are slowly moving to Postgres. Heroku in 2014 was removed to use a dedicated server, and now we are using Google Cloud Platform. And RabbitMQ, we are still questioning ourselves. We are still using it, but yeah, we maybe plan to move to Kafka. But Elasticsearch is still there, and we didn't plan at all to move from it. So how do we use Elasticsearch for one of our use case? We have all the different freelancers present in several indexes. Freelancer, it's an aggregate of data coming from different tables in MongoDB. And so we don't store the data primal in Elasticsearch. It's just a view of the data in MongoDB. We use several indexes for internalization. Internalization. Yeah. So because we have one index for French, not for France. We have one index for Spanish, one index for English, and so on. Each day we rebuild globally the whole indexes. And that's why I said previously that the volume we have today is quite an advantage for us because it's easier to rebuild the index totally each day. In the field source, we have all the informations that allows us to display the results in the search page results. And so we don't have to do some additional round trip to MongoDB to retrieve the informations. I want to do a short focus on the reindexing because that's something that could cause some problems for some of us. I don't know if you had this problem. But when you rebuild your index and when you change your mappings, you have to understand that each time you change your mapping, it's you have to index because you have to destroy your index, you have to recreate it, and you have to re-index all the data. And of course, if we do that at Malt, every time you destroy your index, you don't have any search engine available. So that's quite a problem. In 2012, it was not really a problem, but now it's a problem. So we built a strategy around aliases. We have two aliases. We have one aliases, excuse me, which is, okay, you have one index, and this index has several versions. You have the blue versions and the green versions. Every time you rebuild your index, you recreate, for example, the green version. You re-index all the data to the green version. In the same time, every information, every new event that leads to another document in your index is routed to the blue version and the green version. And when it's done, you can just switch the alias to the green version and you can destroy the old one. So that I think most of the companies that have the same strategies, but yeah, in 2000 we built that in 2013, I think. Yeah, and there was no built-in solution. I don't know if it's the case today, but there was no built-in solution at this time. Now I want to focus on the search query. It will be hard for me to describe you every lines of code on the search query, of course. Yeah, as you can see it, there is quite some zoom here. So the search query, it could be seen as complex, but you can describe the search query in two phases, in two steps. You have the matching phase and the boosting phase. So the matching phase, basically, it's, okay, I want to find the relevant profiles for my query. For example, if I type Java, I want that every profile that comes in return contains the word Java. But it's not that simple, because I want also that the profiles with, I don't know, Jakarta E or GDEC, G2EC comes also with my results. But yeah, that's basically the matching phase. The filters also are in the matching phase. But after that, when you retrieve all your profiles, you want to rank them to understand what is the best for you. The best, that's something that that depends on you, because the best for Elasticsearch is basically something about the frequency of the term in the document. But maybe the best for me is not related to the frequency, and I will explain that. So yeah, it's not really a demo, but I will show you exactly. Oops. So yeah, maybe I can use the ES version. Yeah. So I'm here at Malt, and Louise already show you that, but I can search for Java. Yeah, okay. DevOps. Oops. DevOps in Barcelona. I hope that I will have some results. That's okay. Okay. I was afraid that. I have some results here, and that's why I say that our use case for this presentation is only about the on page and this page. Here you can precise some of the filters, the nivel de experiencia. I don't know if it's okay. The categoria, and some of the filters. Those filters will depend on the results, because you can have some additional filters that will appear because of some conditions. Okay, I return to, no, it's, return to the presentation. Okay, so as I said, first phase is how to retrieve the relevant profiles for me, starting from the words that I type in the field. There is a lot of things that you already know, I think, filters, spot filters, match query, but I want to have a short focus on the three different things here underlined: constant source query, custom analyzer, and synonyms. Why do I speak about custom analyzer? When you use Elasticsearch, every word, every text are analyzed through a default algorithm. Yeah, and yeah, it works quite well. But for queries that you can have at Malt, it's not all. It's not from. It doesn't work every time, because, for example, C# or C++, you will get C every time. because it will strip the different characters sharp and plus plus. And in the text, it could be very short. You can have a mix between different languages. Like in French, we say Franglish to say that you can have a mix between the different languages. You can have some syntax specificities, like for example here, in French, you can say developer. You can have some parentheses to say the termination for women. So you can say with the same words that you are looking for a man or a woman. But that's not really understood by Elasticsearch, of course. And you can have some new names like DevOps that can relate to another job, for example, sysadmin, and that's not that true because DevOps could also be used for some other jobs. And all those rules, you want to capture them in your analyzer. Yeah, here I also say that you can use stemming. I don't know if you use stemming in your analyzer, but stemming can have some effect, some weird effect if you use a strong stemming, like for example Java, that could be shortened to Jav, and sometimes you can have some other tokens that have the same token at the end. So so we don't use stemming. And we took a decision to use a synonym approach with our own dictionary to handle a lot of this case. So for example, here you have all the synonyms for Java, G2E, G2EE, and so on. And we have the same for the different variation of a word in for male, for female, and sometimes you can have some syntax like here, which is English, but that you can find in French. So that's why we use the synonyms, and that's why we had a lot of troubles with the version 6, because there is some differences in the management of synonyms in version 6. So so synonyms for us are quite important, but also we use some tokenizer and some filtering in our chain. One of the most important is this one, ICU folding. It's more powerful than the basic one, which is the ASCII folding. Yeah, I won't discuss a lot about it, but you have a stronger analysis of diacritic characters. Just a few minutes ago, I said that we use a constant scores query. I don't know if you know what is a constant scores query, but in our case, I said that the frequency of the term is not that relevant for us. I think that you all know this formula. This formula is how Elasticsearch we compute the score of one document within your results. And it's basically related to the frequency of the term and the frequency of the term through the whole, through all the documents. But in this sentence, Java is present twice, and it's not for us. It doesn't mean that this document is more relevant than the second one. So we didn't want to use the TF IDF algorithm, and we use a constant scores query that allows us to have a score which is always the same for your query, unless, of course, it match your word. So if you match your word on the title, for example, you will have 1.8, because 1.8 is the weight we have decided for this field, but you never have another score for this field. And yeah, I forgot to say that, but yeah, most of our queries are quite short. So that's why this decision works for us. It won't work for you if you store large documents, because the frequency of a word in a large document is much more related to the frequency, to the relevancy of the document. So, okay, we have a lot of results. Every results have a score determined by only the different fields that match our query. We have the description, we have the headline, the title, we have the tags, and every fields have a different weight. Okay, so basically, if you have the term in the different fields, you have the maximum score. So we have a lot of documents with the maximum score. Now we have to score them according to our comprehension of what the customers are looking for. So the boost, you can apply some boost on every terms. You can have some weights basically for every fields, but you can also have some boosts that you decide after your formula with custom source functions, and I will discuss that. Basically, your position is your boost cross the matching score. The matching score is just the presence of field cross your weight, and the boost is the sum of all boosts. Every boost is related to a functional decision. For example, we have a boost for the conversion rate. We have a boost for your proximity to the freelancer. So we will propose you the people that are closest to you. We have a boost for the last modification date. So we think that if you modify your profile recently, that's because you are more active. And we use for some of those boosts a ghost decay. Many of you know the ghost decay. It's since the beginning in Elasticsearch, and the ghost decay, it's quite easier to understand here, but you have a bonus, and this bonus will decrease, and the I don't know the word in English, but the way it will decrease is that's la pente. The slope, okay. The slope is described by some arguments that you can tell to Elasticsearch. So you can have a strong slope, you can have a slower slope, and yeah, that's something that you can use in Elasticsearch easily. We use a double ghost decay. For example, for the proximity, we use two ghost decay. For example, if you are in the 100 kilometers, you have one decay. But if you are in the 800 kilometers, you have another decay. So basically, you have something like that. So you have a slope here, and you have another slope after that. We use also the script function. The script function, you can say to Elasticsearch, okay, I want to have a score here, which is related to one value in my document. This value in my document has to be lower than something. If it is not lower than something, we will use here. It's not a bonus; it's a malus. And in this case, it's because the freelancer is not active. It doesn't answer to the customers. So we start to have a malus for him. The script function, we use it something. We have 5 or 6 fields where we use this kind of function. Yeah, this one is the illustration of the double ghost decay on the same field. Here is the date of modification. Now we are thinking about another way because, as I said here, every boosts are not related to the others, to the other boost. The ponderation, the weight we use on every boost was made quite empirically. It's hard to add a new boost because every time you add a new boost, you have to observe the results on your search engine, and the only way that you can the only way to observe the results is by observing the conversion rate, but it's not that good because you have to wait a few days, and yeah, of course you can do some manual observation, but you can perform a lot of queries at Malt, and maybe it's good on one or two queries, and it won't be that good on some other queries. So manual observations are not really good for that. And if you think about it, that's a typical problem of machine learning. Finding the weights of every parameters in your function and measuring the precision and the recall of your new function. So that's why we are currently developing a new plugin over Elasticsearch to do the scoring outside Elasticsearch. So we now have a function which is rescore, that allows us to rescore completely the different people, but with a machine learning algorithm that is doing his life outside of Elasticsearch. And we are testing it since a few days, so that's quite new, and we can't say a lot of for the moment. So yeah, I think I'm in time, and thanks for your attention.